Hi class, this is a review of what we're going to be doing for the week. Hopefully this is helpful to you. If it's not, make sure you email me with any questions you may have. So the topic for this week is how we can solve one-step equations. We'll start looking at two-step equations next week, so it's really important that you have the one-step equations down, how to solve them, and more importantly, how to show your work for that. I realize that some of these you may be able to just figure out in your brain. I want you to show your work so that when they get to be longer questions, you can understand and keep everything organized. So before we get into this, a couple things that you have to remember and review. Last week we looked at adding and subtracting integers. I purposefully did not include multiplying and dividing integers. But some things you have to remember when you are multiplying or dividing two negative numbers. For example, maybe you have -3 times -7, you would get a positive 21. Same thing for dividing. If you're dividing -18 divided by -2, you would get a positive number, and that'd be a positive 9. If you have one of each, let's say you have -3 times a positive 7, you would get a -21. Or if you had 18 divided by -2, you would get a -9. So just kind of keep those rules in mind. You can do these on a calculator, and just make sure you put the positive and negative signs where they go on your calculator if you struggle with those. The other thing that we need to review from way back when we were still in school, in the building, was inverse operations. So hopefully you can remember that adding and subtracting are inverse operations because they cancel each other out. For example, oh, there's my alarm. I gotta get my Zoom meeting set up soon. Okay, Google, off alarm. Adding and subtracting are inverse operations because if you have 7 plus -7, or you could even say 7 minus 7, you end up with the additive identity, which is 0. Multiplying and dividing are also inverse operations. Maybe you can see it a little better there without the light on. Because if I have, let's say 6 divided by 6, I get 1. Or if I have 6 times 1/6, I also get 1. So those will help cancel each other out, and then you're just multiplying or dividing by 1, and that doesn't change the result. Or for this case, you're adding or subtracting 0, and that doesn't change the end result either. Feel free to look back to your notes, and you can see that from way back in like March or something. We worked on that. Okay, so those are just things to remember. Here's the type of questions you're going to have this week. So examples for this week of how to solve and show your work for these one-step equations. The first example is, let's say we have 18 equals 6 plus x, some number that we don't know. Again, some of you guys might be able to just think about this. 6 plus what number equals 18? If you're not quite sure, you can always go ahead and show your work. Either way, though, if you know it in your mind beforehand or if you don't, I want you to show your work either way. So when we get to the longer questions, you have that work down with how to write it. So to get rid of adding a positive 6, the inverse operation would be to subtract 6. So if I subtract 6 from this side of the equation, I have to do it to both sides of the equation to keep it balanced. So 6 and the -6 ends up being 0. You don't have to write this part, but you can think 0 plus some unknown number is the same thing as just having that unknown number x. And then on this side of the equation, you can just do the math work. And you can use a calculator if you need to. 18 minus 6 is 12. Okay, example number 2, let's say I have -15 plus y equals -8. And with these positive and negative ones, if you want a calculator, I think that would be a very good idea for a lot of you guys. Or maybe even you just check it afterwards with your calculator to make sure you didn't make any mistakes with your positive and negative numbers. Okay, so this is a plus sign, but this is a negative 15. So the inverse of negative 15 is a positive 15. Negative 15 and positive 15 will cancel each other out. And since I added 15 to this side of the equation, I have to add it to the other side as well. So I'm going to just pull my phone calculator over here. Well, that's kind of hard to see, isn't it? Let me see if I turn this light on, if that will be, there we go. If I turn the light back on, you can see that a little better. So if I have negative 18, so on my phone calculator, I have to actually push the 8 and then the negative sign. And then plus 15 equals a positive 7. So y equals positive 7. This is exactly the way I want to see it. I want to see maybe you circle or square in the answer, but also I want to see the work. I have to see the work for these because we'll be adding on to this next week. Okay, the example number 3, let's say I have m minus 10 equals negative 28. Because this is a negative 10, I'm subtracting 10. Adding 10 will get that to cancel out to be 0. And since I added 10 to the left side, I add 10 to the right side. So then on my calculator, I'm going to type in negative 28 plus 10 equals a negative 18. So m equals negative 18. Okay, for the next one, oops, this is number 4. Example number 4, let's say I have 14x equals negative 42. Well, you have to think about what this means. This does not mean 14 plus x equals negative 42. This means 14 times x. They won't put that little multiplication sign there. They'll just have those together. But you have to remember that this means 14 times x equals negative 42. So the inverse of multiplying is dividing. The way I'm going to show that here is I'm going to show that I'm dividing each side of the equation by 14. So 14 divided by 14 is 1, or 1x. And then on my calculator, I'm going to type in negative 42 divided by 14. And the answer is x equals negative 3. Okay, I have 4 more examples for you. I'll go through these ones a little faster. Number 5. If I have negative 5 equals y divided by 12, to get rid of dividing by something, the inverse of that is to multiply. So because I multiply the one side of the equation by positive 12, I'm going to multiply both sides of the equation by positive 12. So on my calculator, I can do 12 times negative 5, and the answer is negative 60. For the next one, let's say I have negative 8t equals 40. Something like this is a problem that students sometimes make mistakes on because they think of this as a negative 8 plus t, so then they want to add 8 to get it to cancel. Remember that this means negative 8 times t. So because this means negative 8 times t, you have to divide. Divide each side by negative 8. So here's how your work would look. You would show that you're dividing each side by negative 8. So that positive 1t equals, and then you can do 40 divided by negative 8, and you get negative 5. Okay, 2 more. Number 7. If I have 12 equals n, and it looks like this, what this means is n divided by 4. So I'm going to multiply each side of this equation by 4. These cancel out. And then I can take 4 times 12, and I get 48. And then the last one, the last example, negative 8z equals negative 64. This is multiplication, just like this last one, so I'm going to divide each side by -8. So z equals, when you're dividing two negatives, if you're having a hard time on your calculator, if you just remember that the overall result will be positive, then maybe you could just do 64 divided by 8. If not, you can always do all of this on your calculator with the negative signs. Just make sure you type in a negative sign for each one. -64 divided by -8 is a +8. And there you go. Please let me know if you have any questions. There's plenty of online resources for this if you need extra practice. I have also attached in Google Classroom the problems with the answers. Unfortunately, the work for those answers are not there, so reference this if you need to see how the work is done for the upcoming assessment. Have a great day.